everyone, and welcome to Fermilab's Virtual Earth Week. My name is Sue Steyer, and I'll be moderating today's event, Climate Action, a Better Future for You and the Planet. Our presenter, Kathy Clarkin, is an education facilitator at Fermilab and an environmental chemist. We will be recording this presentation. Your cameras and mics will be turned off, but please use the chat box for questions and for answers to questions that Kathy asks us. We'll stop several times during the presentation to answer questions as time permits. At the end of the presentation, I'll put an email address in the chat box for you to send us any questions that we aren't able to get to or that come to you later. And now, our presentation.
Hi, everyone. Thanks for coming today. I know that we have some students here, so I'm really excited to have you here. So again, I'm going to be talking about climate action, a better future for you and the planet. And there we go. So Jane Goodall famously said, you cannot get through a single day without having an impact on the world around you. What you do makes a difference, and you have to decide what kind of difference you want to make. So I hope that as we go through this presentation, and maybe you've already thought about this, but what kind of difference can you make when it comes to climate change? I'm hoping that we can make this interactive, especially since we have some students here. So I will be asking you questions, and I hope that you'll ask me questions as well, so you can put those in the chat. And so let me just give you a quick overview of today. So if we're going to talk about climate action and climate solutions, first we need to understand what is the problem, what is climate change, and what causes it, and what are its impacts. And then next, we'll start talking about solutions. This is the optimistic part of the talk, how we can actually work on climate solutions. And importantly, what you can do and what we can all do together to take climate action. So we're going to start off with a question that I have for you. And I really hope that everyone does participate by typing in the chat, because we can all learn from each other. So can you tell me, how do we know that climate change is real, that it's really happening? What is the evidence? Can you share what you know already about that? We'll give it a minute or two.
Oh, we're getting some answers. Rising sea levels, severe weather more often. I'm not seeing any more answers.
All right, let's give it another couple seconds.
Shifting seasons.
All right.
That's
great.
all I see.
Okay, great. So everything that I heard so far is that we have evidence of the impacts of climate change. So I'm going to talk a little bit about what causes those impacts to begin with. And maybe for some of you, this will be a review, and some of it, maybe you haven't thought of it in this way before. So I'm sure that you've all experienced getting in your car on a sunny day, and it's hotter inside the car than outside. And that's just like a greenhouse. It gets hotter inside. That sun makes the heat get trapped inside. So the same thing, so we call this the greenhouse effect. And so the same thing happens with the atmosphere. The atmosphere traps some of the heat that comes from the sun and bounces back off the earth close to the earth. That is the greenhouse effect. So let's dig into that a little bit for a moment. So the sun shines down on the earth, and then we have what we call greenhouse gases in the atmosphere. So those are things like CO2, carbon dioxide, and methane, CH4. And some of that heat that bounces back up off the Earth's surface keeps going out into outer space, but some is trapped by these greenhouse gases. But then we start doing things like burning fossil fuels in our vehicles, like gasoline and diesel. And that's going to put more of these greenhouse gases into the atmosphere, trapping more heat. And then even things like cow burps put greenhouse gases into the atmosphere. And the way that we manufacture things in certain industries put more and more greenhouse gases into the atmosphere, trapping more heat. So where do all these greenhouse gases come from? Well, they come from us, the 7.8 billion people on the planet, driving 1.4 billion motor vehicles that burn gasoline and diesel, emitting greenhouse gases. We use 2 billion personal computers and 8 billion mobile phones on the planet, and many of those are charged with electricity that comes from coal and natural gas, which again emits greenhouse gases. We use enough concrete for our roads and our buildings to cover the entire earth 2 millimeters thick. And concrete, the production of concrete actually has a huge climate impact. On Earth, we use every single year the same mass of plastic as the mass of every single person on the planet. And that's every single year. And that has a carbon footprint. So all of these things and others are emitting 50 gigatons. That's 50 billion tons of carbon dioxide equivalents per year, which is equal to the mass of 250 million blue whales, the largest mammal on the planet. So how do we know that these greenhouse gases trap heat? Well, again, science gives us the tools to understand. So this experiment was done originally in the mid-1800s by Eunice Foote, who's pictured here. She was a rare woman scientist of the time, and she demonstrated that carbon dioxide does trap heat. And you can even look up online how to do the experiment yourself. So you can, again, science is giving you the tools to understand that greenhouse gases trap heat. Now let's look at how this extra heat has warmed the planet. This is an animation of temperature changes across the globe from 1880 to 2020. And you'll notice when we get to around 1980, the temperatures are really starting to rise, and that temperature increase is not even across the globe. So the average increase over this period is about 1.1 degrees Celsius or 2 degrees Fahrenheit. So now I have another question for you. To me, 2 degrees Fahrenheit does not sound like that big a deal. If I'm out in the prairie at Fermilab and it's 80 degrees or 82 degrees, I don't even notice the difference. So why do you think we should be worried about a 2 degree Fahrenheit or 1.1 degrees Celsius increase in temperature? Can you put in the chat what you think? Why is this a concern?
I'm still waiting.
All right.
Oh, here's something. All right, glacier melt. Glaciers will melt, causing water levels to rise and flood the earth. 1.2 is an average, actually much later in some places, and besides, it's huge. 2 degrees across the planet is an average over everything, but that can affect individual spots more severely. That's all so far.
Oh, that's excellent. We have a really well-informed audience here. I think when I first started to hear about climate change and global warming, I questioned that. Why is 2 degrees Fahrenheit such a big deal? And if you talk to somebody who hasn't really spent much time thinking about climate change, that might be a question that you hear. So we heard some of your answers. Yes, that when you take that and average it across the globe, across all the atmosphere, which is huge, that represents a lot of energy. And here at Fermilab, we'd like to think in terms of energy. So that energy does things like we heard melting glaciers, and it causes more water to evaporate, which leads to drought in some places. And as somebody said, things are not distributed evenly across the globe. So drought in one place and that evaporated water raining down in heavier storms in other places. So even though it seems like a tiny increase in temperature, it can wreak a lot of havoc because it's so much energy. So just to sum up this part, global warming, climate change is caused by greenhouse gases, not just the carbon dioxide and methane that I mentioned before, but also nitrous oxide, fluorinated refrigerants, and a few others. And these come from burning fossil fuels for our buildings and our transportation, the way that we do agriculture, how we use land, deforestation, forest fires, and certain types of industry. So all of these things are causing our climate to change, but ultimately the cause is what we decide to do. Do we decide to continue doing what we're doing, putting greenhouse gases into the atmosphere, or do we make another decision to pursue clean, green energy and stop emitting all these greenhouse gases? So since we have students here and maybe some of you adults have students in your life, we wanted to mention a few climate, some careers that relate to understanding climate change, what it is, what causes it. And so here are a few that I have listed here. I'll just mention, since we are a particle physics lab and we have a lot of physicists here, a physicist or a computer scientist would build climate models to understand, as we add more greenhouse gases into the atmosphere, what happens. And those models are based on principles of physics, like conservation of energy, conservation of matter, and conservation of momentum. So that's just one that I'll highlight. So I think in the interest of time, I'm not going to ask you this question because I already heard a lot of answers. What are the impacts of climate change? So, you know, the strong storms and the rising sea levels and so forth. But there are really two buckets when we think of the impacts of climate change. So though there are all those environmental impacts that you and I have already mentioned, obviously hotter temperatures. And somebody mentioned earlier on changes in season. So if we have things blooming earlier because we have a shorter winter, that can get out of sync with our pollinators. And then we have fewer insects, and then that leads to fewer birds feeding on the insects. So the loss of biodiversity is another impact of environmental impact of climate change. But we also have humanitarian impacts. All of these environmental impacts are leading to human impacts. So things like medically vulnerable people are going to be more vulnerable to those hot days and hot nights. People who are impacted by droughts and floods may be displaced from their homes, or they may have loss of property, and that may cause economic strain. It can even lead to armed conflict and violence. So when we talk about climate change, we're not just talking about these environmental problems, but human problems. So if you care about human beings, you care about climate change. And here are just a handful of careers related to understanding or working on the impacts of climate change. And I'll just highlight one that might look kind of funny to be under the human impacts, but a civil engineer would maybe work on building infrastructure like buildings and roads and bridges and so forth that are able to withstand the impacts of climate change. So I want to end this part of the talk with this quote from Bill McKibben, because I think it kind of sums up what we just talked about. So we've been given a warning by science and a wake-up call by nature. The next part of the talk is it is up to us now to heed them. So the next part of the talk is about climate solutions. What are we going to do since we have this wake-up call? So can you share with me what you know about what is already being done to address climate change? What are some climate solutions, or what are governments or individuals or businesses doing to lower our carbon footprint, reduce our greenhouse gas emissions?
All right, we're starting to get some answers. Recycling, electric cars, we have time for just a couple of more. If anyone has some other ideas. Okay, solar panels and reusable bags. Solar.
Okay. All right. Yep. All good things to do. So we'll dig into that a little bit more about what's being done. But first, I want to share another quote with you. This is from Jonathan Foley, who is part of Project Drawdown, which is a research organization that studies climate solutions. And he says, "I'm convinced we have the solutions and technologies at our fingerprint tips to solve this problem. We get to build the future we want. The future is ours to choose." So the reason that I like this is because it's optimistic and it's from somebody who studies these things. So if we start focusing on building that future that we want to build, then we're not focusing so much on all of those impacts and scary things that are happening and will happen if we continue to warm the planet. If we spend our time focusing on using this technology that's at our fingertips, we can solve this problem and we can contribute. So Project Drawdown gets its name from the concept of drawdown, which is the point in the future when we've stopped putting greenhouse gases into the atmosphere and the concentration of those gases slowly starts to decrease. So our goal is to work quickly to get to that blue dot on the graph to stop the emissions of greenhouse gases and to stop even more catastrophic impacts of climate change. So to reach drawdown, many of you mentioned some things in this category of mitigation, which is reactions to reduce emissions that cause climate change. So that's to reduce our sources of greenhouse gas emissions, but also support sinks. So a carbon sink is the parts of nature that hold on to carbon rather than releasing it. But there's something else that we have to do when we address climate change, and that's we need to adapt. So those are the actions we take to manage the risk of climate change impacts. So you've mentioned some of these mitigation efforts. I'll just reiterate them. So we want to replace our fossil fuel energy with clean energy like wind and solar. Change our internal combustion vehicles that are burning gas and diesel, change them out to electric vehicles or other ways of getting around like public transportation or safe walking and biking routes. We need to address how much we consume, what it's made of, what its life cycle is. We need to reduce food waste, which is another topic of one of our talks this week on Fermi Earth Week. All of those things that we buy have a carbon footprint. So we want to work towards a more circular economy where we're reducing and reusing and recycling. Because somebody mentioned recycling is something that you can do to address climate change. And when you recycle, you are avoiding a lot of greenhouse gas emissions from the original extraction and processing and shipping of virgin materials. So it is a really important part of climate solutions. And then we need to also change the way that we manufacture some things. For adaptation, that's again, actions to manage the risks that we already have from climate change. So that's things like stormwater management, building stronger infrastructure to withstand strong storms, changing things like building codes. So like, for example, you can no longer build in a floodplain. And then we have actions that we can take that both mitigate and adapt, help us to adapt. And a lot of those are nature-based solutions. So like here at Fermilab, we have native woodland and prairie, and wetland. So we're gonna protect all of those areas and make sure that they continue to function. We need to conserve and protect our oceans and conserve water. So let me tell you a little bit more about a nature-based solution. So here at Fermilab, we have a herd of bison, and like bison, they are ruminants that eat grasses, and their burps do produce methane, but less than half that of a cow. So their burps do emit greenhouse gases. However, when bison are part of a healthy native ecosystem, their presence can mean that more carbon is sequestered in the plants and animals and soil in that ecosystem. So that ecosystem becomes a carbon sink. In a native landscape, bison actually help the ecosystem function better, leading to higher rates of, did I already say that? I'm sorry. Part of the reason they are so helpful to a native prairie ecosystem is because their poop provides essential nutrients to plants and insects like dung beetles at the bottom of the food chain. And their hooves actually disturb the soil, making it more difficult for a native or non-native species to grow. So conserving bison has multiple benefits. And that's just one example of how conserving an ecosystem and working towards these nature-based solutions can help with climate change. So we're already doing all of these things, but we need to do them faster so that we get to Drawdown as quickly as possible to avoid further climate disaster. Climate modelers tell us that in order to avoid a really devastating outcome, warming must not exceed 1.5 degrees Celsius. Remember I said we're already at about 1.1 degrees Celsius above levels from 1880. So without rapid mitigation efforts, the planet is on track for much greater warming. But this is the optimistic part of the presentation. So let's think about what the world will look like if we do decide to address climate change. So let's not focus on all of the devastation that will happen if we continue to warm the planet. Let's think about what the planet will look like if we address climate change. So type in the chat anything you can think of, like how will you be moving around? How much plastic will be out there? What will your home look like? How will you be cooking or heating or cooling your home? What will you be eating?
All right, we're getting some answers. We have solar homes, cleaner air, healthier lungs, less respiratory disease, more efficient factories. I'll just wait a moment more to see if
Yeah.
there's anything else. No, I'm not seeing anything else.
Okay. All right. I'm gonna put this slide up here. It has a lot of words on there, but one of the things I heard all of you mention were things like healthier air to breathe. So when we tackle climate change, we're also getting a bunch of co-benefits from that. So if you're not burning coal in a coal-fired plant, or you're not driving a car burning gasoline or diesel down the highway, you have less air pollution. When you have less air pollution, you have healthier air to breathe. So tackling climate change, we also are tackling these other problems and getting all these other co-benefits, like I've listed here. And when we think about climate solutions, we want to think in terms of not creating more problems, but solving one problem and creating another problem. So we try to think in terms of how can we address climate change, keeping in mind gender and racial equity, environmental justice, making sure that as we create clean energy jobs, green economy jobs, that there's equal access to those benefits. Let me give you just another quick example. Right now, there is not equal access to electric vehicles, which we know are less polluting, produce fewer greenhouse gases, and are cheaper over the life of the car. They're cheaper to maintain. You save money by not having to go to the gas pump, but there is not equal access to that now because people who live in apartments or condos don't have a place at home to charge. And charging stations are still not very widespread, and it's more expensive to charge at a charging station than in your home. So we want to build these solutions, keeping in mind that we want equitable access to the benefits of them. If anyone has any questions, I know there's a lot of words on this slide. I don't want to go into all the details, but if you have any questions about any of these, you can put them in the chat and we'll get to them towards the end. So I just like this, this little cartoon here, because this is the kind of future that I want to build with these climate solutions and all these co-benefits that we get with them. So it's going to take all of us, though, to build that type of future. And I have a whole bunch of careers listed here, but the idea is that every job can either have a positive impact on the climate or a negative one. So whether you want to be a scientist or a fashion designer or a chef or a Wall Street investor, you can make choices to be part of climate solutions. And going back to Jane Goodall, you have to decide what kind of difference you want to make. And let me just highlight one here, that just one on this long list, a nurse. So a nurse is not going to be figuring out how to reduce greenhouse gas emissions or pull them out of the air or anything, but what they're doing is they're part of that working to help people who are impacted by climate change, which is an important part of addressing climate change. It's not, so a nurse is going to help people that are stressed by heating, or, you know, maybe even there's waterborne disease from flooding or what have you. So climate solutions is not just solving greenhouse gases in that atmosphere, it's helping people who are impacted by climate change. So again, every job is a climate job. You have to decide what kind of difference you want to make. One that helps solve the problem or one that contributes to it. So we're going to have time at the end for you to tell me about what you're going to do, and hopefully we can inspire each other. But first, I want to kind of give you a couple ways to think a little more deeply about this. So there's a well-known climate communicator named Ayanna Elizabeth Johnson. She's an oceanographer as well, and she famously talks about this Venn diagram. So there are lots of problems that need solving when it comes to climate change. We've talked about many of them today. And then there are the things that you're interested in or you're passionate about. So to contribute to solving these problems, you don't have to develop new interests or be somebody that you aren't. You can just be yourself. And then you may have skills already, or you know that you can develop skills through your education or just learning from other people or online. So where you can really make a difference is when you find that spot right in the middle. So let me give you just a couple really quick examples. So a problem that needs solving, for example, is fast fashion. I'm not sure if you've heard of that term, but it's people far away working in poor conditions are sewing our clothes for us. Our clothes get put on shipping containers, and then maybe they go to an Amazon warehouse, and then we order them and they get delivered to us, and then we wear them and they wear out quickly, and then that becomes garbage. So that is a problem because it has a huge carbon impact, a big carbon footprint. So maybe you're interested in, maybe you're a crafter and you can figure out how to take old materials and make them into something new. We call that upcycling. Or maybe you're interested in fashion and you want to go study fashion design. So probably anything that you can think of, any interests that you have, you can figure out how you can connect it to problems that need solving. So when discussing personal climate action, people often think of how they can lower their own carbon footprint. And this is a good thing to do, and it's great if everyone does their best. It's good to live in terms of your own values, but the fact is that this is not the solution to climate change in and of itself. It's good to do, just like it's good to vote. Everyone doing their part, but the fact is that sometimes we don't have a good choice available to us. So for example, I live in a community where most of our electricity comes from coal, and I have a house that has shaded rooftop, so I can't have solar. So I don't have a good choice to lower my carbon footprint for my electricity bill. So what really needs to be done is to have systems and policies changed so that the right decision becomes the climate positive one. So if my community got their electricity from renewable energy, then I wouldn't have to worry about that I can't put solar on my rooftop. So how can you and me and all of us work towards these system and policy changes? So first, it may surprise you that simply talking about climate change with your friends, families, coworkers, classmates will make a difference. The more awareness there is, the more people's mindsets change, so that people making decisions start thinking in terms of how those impact the climate. So the more we talk about it, the more political will we generate, and the more that we become part of a community. So second, if you want to see change where you live or work or go to school, join with others and work towards change. And you can even join a climate movement. This is what has resulted in change in our country over and over again. A good example is in the 1970s, there was a big Save the Whale campaign. And because of that movement, that environmental movement, in 1982, there was an international ban on commercial whaling. So joining a movement can really make a difference. And then we all have influence somewhere in our lives, so figure out where that is and use it to drive climate action. So whether you work in a fast food restaurant and can decide to give out 1 or 2 fewer napkins that end up in everybody's trash anyway, or you're the CEO of a company and can put solar on the rooftop, you have influence somewhere. I know I've been talking to students who are working to influence their school to put solar on top of their school. So figure out where that is and always make sure that you vote. That's important, and you can even volunteer for a candidate or run for office yourself. So I would love to hear from all of you what you're doing or what you want to do when it comes to climate action, because it's important that we all support each other and get inspired by each other. So if you could put in the chat.
Well, let's give people a chance because
Yeah.
I'm sure they're writing a lot.
Yeah.
I put in the chat that I'm going to compost more.
Ah, good. Maybe you could talk about your stewardship too. You're also doing stewardship, I know.
Oh, I can do more stewardship at Fermilab to help remove invasives that choke out the native plants, and then choking out the native plants ends up disrupting the whole food web. So we want to keep the food web intact so that the whole ecosystem can work better together. And Thomas says, working in sustainability already. So thanks, Thomas. Keep at it.
Yep.
Here's another one. Our household is moving toward using less plastics in many areas. That is shampoo, processed foods, water filters with water from the sink, and using laundry sheets and no plastic detergent bottles.
That's awesome. Yeah, that's a huge challenge, the plastic challenge, because it's really hard to get away from plastic. You have to kind of do a lot of work to figure out alternatives. So imagine we had some other kind of circular economy or better ways that things were recycled, or you could have reusable bottles. Wouldn't that be great? Then again, we would have a system where you don't even really have to think about it. It's the right choice for the climate. So that's what we need to work towards. But I do some of that too. I use those little laundry sheets instead of a big plastic bottle. Yeah.
I'm waiting for. I haven't heard from any students out there.
Oh yeah.
I'm hoping to hear from them. But some of us of a certain age remember when we would return bottles.
Yeah.
or a deposit, and I think some states still do that.
Mm-hmm.
So that's a great way to get rid of plastics.
Yeah.
I'm not seeing any more answers here, but what I'll do is I am going to put in an email address if you have any questions that weren't answered today, or if something comes to you, you can simply email your question to this address.
All right. Well, let me just sum everything up real quick then. So science gives us the tools we need to understand climate change. Every job can be a climate job. Solutions to mitigate and adapt to climate change exist, and you can make a difference. So thank you everyone for coming, and thank you for everyone who participated. And again, yeah, reach out if you have any comments or questions. We'd be happy to get back to you.
Thank you, everyone.
Thank you.